We're finishing up chapter 5.3, y'all. We're doing exponential functions. Yesterday, I showed you how to graph these things. I hope you're able to graph those on my math lab without any issues. I showed you how to do it by hand, but also how to use your calculator. So hopefully, if you have issues, let me know. I sang to you yesterday the number E song, so hopefully you know E 2.718. Again, that's the approximation of that fancy number. Okay, we'll do the applications of that and how that was derived later second semester. Then in goal number 3, this is what we're going to focus on in examples 2, 3, and 4. We're going to solve those exponential equations. Okay, well, let's go back to graphs. We should be able to graph given an equation, and now the idea on example 1 is if you have a graph, you should be able to come up with the equation. So doing the opposite, doing what we call the converse. So if you have the equation, you should be able to graph it. Now, if you have a graph, you should be able to come up with the equation. Well, the things that we're going to look for are what we call the K value. The K value is your stretch, your multiplier. It's going to be your vertical stretch, or if it's a fraction, it's going to be a compression. Okay. And then the other thing we're going to find is our base. So there's going to be 2 things that we have to find. Okay, so we need to find K and we need to find A, or base. Well, the easiest thing for us to find is K. We're going to find this guy first. And to do that, we're going to use our coordinate points. Okay, so these are 3 coordinate points that are on our graph. And the point we want to use first is the one with the 0. And I'll show you why here in a second. Again, remember, a coordinate point is x comma y. We're going to take this 0 for x and the y for the 1/2 for y. We're going to plug that in. Okay, so again, I'm going to use this equation. I got y equals k times a to the x. And plug in. So I got y is 1/2. K is k. We're going to try to find that. We don't know a yet, so a is a. And then x is 0. Okay. This is why I chose the one with the 0, is because I should know what anything raised to the 0 power is. You guys know what anything raised to the 0 power is? If you're not sure, take Mr. Gotch's salary, which is $2 million a year, and put it to the 0 power. What is any number raised to the 0?
1.
We get 1. Fantastic. So that's 1. All right. So a to the 0 is 1. 1 times k is k, and we get k as 1/2. Okay. So actually, now that we know that, this is really 0 comma k. Okay. That's not okay. That's the 0 number, right? And then the letter k. So whatever's with the 0 is your k value. Okay. Now that we have k, now we can find a. So we do that second. So we have our equation. We have y equals k. K is 1/2. And we have a to the x. And now this is where you can use either one of these points. It doesn't matter. I would probably use the one with the 1 and plug that in. Again, this is x, this is y. So I got y equals 5/2 equals 1/2. A is what we're trying to solve for, and then x is 1. Well, a to the first is just a, and now we need to get rid of this 1/2. Well, how do we get rid of the 1/2? How do we solve for a? What do you think?
Multiply by 2.
Yeah, just multiply by the reciprocal. So 2 over 1, divide by 1/2, whatever you want to say. Divide by 2, and we end up with 5 equals a, or a equals 5. So now I got a, now I got k. I plug that in, and I've got y equals 1/2 for k. A is 5, so times 5, and then to the x power. Okay. You could also write this as 5 to the x power over 2. That would be fine too. Just as long as you know it's just the 5 is raised to the x. All right. So given a graph, we should now be able to find any multiplier, vertical stretch, and any base value. Okay. All right, all right. Do we have any questions on example 1? No questions. All right, last but not least, guys, we have 3 quick examples before we get out of here. We'll get out of here nice and early today. Here's our little rule when we're solving exponential equations. It says here, if I have an exponential equal an exponential, and the bases are the same, then the exponents must be equal. Okay, so again, if the bases are the same, then the exponents must be equal, and that's how we're going to solve for x today. Okay, so when I take a look, and I'll zoom in here so we can see this a little, exponents are pretty small. Can you guys see that all right? We're okay with that? If you can't see, I'll read it out here. I've got 2 raised to the 5x minus 3 power, and that equals 4. Well, what I see is I have a base of 2 and I have a base of 4. I can take the bigger base and change that guy. All right, we know 4 can be written as 2 squared, right? So now I have 2 to the 5x minus 3, and that equals 2 squared. Well, my bases are the same. My exponents must be equal. So it's like I just cover the bases up and write the exponents. It's like they cancel out. Okay, and then it's just algebra from there. Okay, so we just add the 3 over. We get 5x equals 5, and then divide. We should end up with x equals 1. So if the bases are the same, set your exponents equal. Just completely get rid of your bases. You don't need them anymore. And we should get x equals 1. Okay. Nice thing is it's super easy to check. Just take that guy and plug it in. You can probably do it in your head. 5 times 1 is 5. 5 minus 3 is 2, and 2 squared is 4. So it works out perfect. Okay. All right, let's take a look at example 3. Any questions with 2 before we do 3? No questions. All right, who can we change? Can we change 5 or 25?
25.
25, here we go. We know 25 is 5 squared, right? Well, that's raised to the 3x power. And if you remember, I think it was like one of our first days together, I showed you the appendix 1, which was powers of exponents. When it's power to a power, you guys remember what to do with these guys? Power to a power? What do you guys get there?
Multiply?
Yeah, you multiply. Yeah, 2 times 3x is 6x. Boom. Okay. And now that's equal to 5 to the x squared power. Fantastic. Questions on how we got 5 to the 6x? We're okay with that. Bases are the same. They're both 5. Set my exponents equal. Set x squared equal to 6x. Get your stuff on one side. We got a quadratic here. This is a little different than this one. This is a linear equation. This is a quadratic. We got lots of ways to solve quadratics. Can you guys give me one way to solve a quadratic equation? What can we do here now that we got our stuff equal to 0? Yeah, we can factor. Teach me how to factor. Teach me how to factor. You could also do what? If you have a quadratic, we can always solve using the...
Quadratic formula?
Yeah, so if you really needed to, if you're in a bind and you can't factor, then try the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But with this one, factors nicely, right? So that's your options. If you really wanted to, you do complete in the square, but nobody wants to do that. So let's just factor this thing. It'd be easy. Take an x out. That leaves me with x minus 6 equals 0. and then set each one of these equal to 0. So take x and set it equal to 0, we get 0. And then take x minus 6 equal to 0, we'd add it over, we would get positive 6. Remember, when you have a quadratic, when you have an x squared, like 90% of the time, 99% of the time, you're going to get 2 solutions. So make sure you get 2 of them. The problem we get is people get to this point here, and then they divide by x, okay? And then they do get 6, but they don't get the 0. So make sure you get the 0 by getting your stuff equal to 0 and factored out. Okay, so we should get 2 answers. And now you can check this if you want. You can plug it in here. You can plug it in here. 0 squared is 0. 5 to the 0 is 1. 6 times 0 is 0. 5 to 0 is 1. So that works. Plug in 6. You get 6 squared is 36, and 6 times 6 is 36. So that works out. All right, or you can plug it back in here and it'll work out. Whatever you need. All right, any questions with that one? All right, so you might solve and get a linear equation. You might solve, get a quadratic equation. All right, the last one I wanted to show you is because sometimes when you look at it, you end up with a fraction. All right, we get 16 to the x equals 1/2. So what we need to do is first off look at this fraction. Is there another way we can write 1/2 so that it's just like a base to a power? Does anybody know how to change that guy around? What do you guys think? Throw out some ideas. This is called brainstorming. Just throw out some ideas. Yeah, so this is the inverse. Very good. So I can bring this guy uptown by making it 2 to the negative first power. Nice job. Okay. Another thing we talked about way back in the appendix 1. Okay. Something we learned in algebra 1, algebra 2. So this is the inverse. If it's downtown, shoot it uptown, make it a negative exponent. So now I got my base like I have up here. I have my a to the v, right? Well, 16, we can change that guy around, right? What's 16 as a base of 2? 2 to the, give me fingers. How many fingers? What is 16? 2 to the 4, Mary says 4. And that's to the x power, so 4 times x is 4x. All right. So I changed 16 to 2 to the 4th. I'll even put parentheses here. That turns into 2 to the 4x when I multiply, and that equals 2 to the negative 1. Bases are the same. Exponents must be equal. So we get 4x equals negative 1, and we divide. Final answer, negative 1/4. And then if I want to, I can plug that in right here, right? If I take 16 to the negative 1/4 power in my calculator, I'm going to get 0.5 or 1/2. And that's what we have over there. Okay. So guys, that's the 3 different scenarios you're going to run into. One where you solve it's a linear equation, one where you solve it's a quadratic, and we got different ways to solve those, and then one where it involves a fraction and what to do with that. And then that's it, guys. You have 5-3 in my math lab, day 2. Try to get those both done for tomorrow so I can take questions.